What is the area of a square field that measures X meters on each side? Well, let's draw it. Let's draw a square. This is going to not look right. I'll go ahead and warn you. There we go. There's a square. Hey, that's not too bad. The top's a little crooked, but whatever. And it measures X meters on each side. Well, it's a square, so all the sides are the same. There we go, X. And then what is the area? So the area of this thing is, please don't think too hard. It's, well, length times width. And the area of a square is X times X. So it's X squared. And then the perimeter is, well, X plus X plus X plus X. X times 4, basically. So if you wasted your time, you'd write this. But really, it's 4x, okay? Because the perimeter is the distance around, right? Okay, so now we're going to suppose the same square field is expanded by 4 meters on its length and 3 units on its width. I'm going to say this is the length and that'll be the width, right? And we can turn that around. It's not going to be a big deal in our computation. What's its area? What's its perimeter? Ooh, okay. So we're going to expand it by 4 over here, okay? And by 3 over here. How do you know how far to draw it? Don't worry, it's not drawn to scale. Now, if you want to get really picky about this, you could do that. And you could say, well, that looks like the box method. Yeah, it does, doesn't it? Not a coincidence. The area of this thing is going to be X plus 3, okay, times X plus 4. It's length times width, base times height. Call it what you will. Take one side, multiply it by the other if they're perpendicular. And it's a square or a rectangle. Okay, so we've done this. We just did this on the front side of the paper, and we're going to distribute. So we're going to go X times X times 4. X times X is X squared. X times 4 is 4X. And then we're going to do the same thing here. We're going to go 3 times X, 3 times 4. So 3x plus 12, and that's going to give me x squared plus 7x plus 12. Yeah, all right, they asked for the area, and we just found it. Now, don't panic, because they asked for area, and you got like something with x's in it. That's okay. Now, the perimeter is going to be a little bit different. Let's start labeling some stuff. Okay, perimeter is the outer edge. So this length is x, that length is 3, this length is x, that length is 4, this length is 3, this length is x. And so if you really want to glance ahead, you can notice that when we add the outer edges, we have x plus 3 times 2 and x plus 4 times 2. Now you could say x plus 3 plus x plus 4 plus 3 plus x plus 4 plus x. That was a lot. It was a mouthful, and you'd have to put your like terms together, but let's not, okay? The perimeter here is going to be 2 of those, and because one here, and then 2 of those, and now we'll just simplify. Distribute the 2's. So 2x plus 6 plus 2x plus 8. And now we put our like terms together. 2 plus 2, I think it's 4. 6 plus 8, I think it's 14. There we go. Okay, so now we're going to do the same thing here, but it's going to be a little trickier. We're going to find the length of each missing side of this figure and find its perimeter and its area. And so this is not going to be as hard as you think it is, actually. Let's just look at the length of these sides. This side, I don't know it, but it's comprised of this one plus this one. Like together, this plus this would make the whole distance, right? So it's same as up here, right? So this whole thing up here is going to be, post-it note time. Now I'll keep it on the paper. This whole distance up here is going to be y plus 4 plus 2y. So y plus 4 plus 2y. And you're probably like, it's too much. I agree. Y plus 4 plus 2y, well, that looks like y plus 2. That'd be 3y right there. 3y plus 4. There we go. Well, it's hard to see, isn't it? It's blurry. Hate it when that happens. And that 4 looks ugly too. I'm going to clean it up. I'll make it a pretty 4. There we go. Much better. Okay, well this length right here is, well, let's look at the other vertical ones. 5 and 2y plus 1. So this is 2y plus 1 plus 5. Well, 2y plus 1 plus 5, that's just 2y plus 6. There we go. So let's find its perimeter. Okay, so perimeter. Our little bag of tricks we used on the last one, we were like, this times 2 plus this times 2. It actually would work here. I'm going to choose not to do it. Let's start in this corner and just drive around it and add everything we see. So if I went from here to here, I'd have 3y plus 4. Don't do this twice, right? So 3y plus 4 plus 2y plus 1 plus 2y plus 5 plus y plus 4 plus 2y plus 6. That's a lot, but it gets cleaned up very quickly. Let's put all our y's together. 3y plus 2y plus 2y plus y plus 2y. 3 plus 2 plus 2 plus 1 plus 2 is 5, 6, 7, 8, 9, 10. All right, now we just add the regular numbers. 4 plus 1 plus 5 plus 4 plus 6. 5 plus 5 is 10, 14, 20. Done. But we have to find the area too. This one's going to be, this one's a beast right here, okay? So the area of this thing, let's switch to Post-it note for just a second. If I wanted to know the area of this right here, then I'd be like, I don't know what to do. Well, here's what you would do. Let's pretend like it's one big rectangle. And you would do length times width. I'm making up numbers here, okay? Just so 7 and 10. If this is 10 and this is 7, I'd be like, oh my goodness, it's 7 times 10, it'd be 70. Yeah, but I'm going to subtract out this piece I'm missing. Again, I'm making up numbers. If this was 3 and this was 2, I'd be like, well, minus that 2 by 3 piece, I would do that. That's exactly what I'm about to do. Exactly. The area of this thing is this, 3y plus 4, times 2y plus 6, minus this little piece right here. And this is the rectangle I'm missing. I'm going to subtract the part I don't have. That's 2y times 5. Let's put the whole thing in parentheses just for fun. And then we'll start distributing and voiling and all this kind of fun stuff. So we're going to multiply those together. 3y times 2y, 6y. By the way, I know to do that because there's no addition here or subtraction. I will subtract this, of course. So 2 things multiplied by 2 things. I'm going to get 4 terms. 6y squared, 18y, 8y, 24, minus 10y right there. Okay? And now we have a whole bunch of like terms that go together. Well, not a whole bunch, just a few. 6y squared, and then 18 plus 8, it's 26. 26 minus 10 is 16. And then plus 24. And even though the answer is not a number, it has a variable in it, that is correct.